Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the ugly number problem. An ugly number is a positive integer whose prime factors are limited to 2, 3, and 5. Given an integer n, return true if n is an ugly number. So for example, 6 is an ugly number because if you do a prime factorization, that's 2 and 3. N equals 1 is an ugly number because because this is telling us how the degenerate case works, and I suspect this is to work nicely with APIs in a lot of languages. Basically, in fact, it'll make the algorithm I'm thinking of in my head already easier too. Basically, if you take the prime factorization of this, it's an empty list. So 2, 3, and 5 are the only things. Well, the list does not contain anything that is not 2, 3, and 5. That's the condition we need to hit. 14, the prime factorization is 2 and 7. That list is not limited to 2, 3, and 5. It has a 7 in it, so it's out. If we had something like a 12, that's a 2, 2, and a 3. That would also be an ugly number, because although it contains 2 2s, that's fine. This set of factors is made only of 2s, 3s, and 5s. God, please, this is an easy problem. I have spent this week fighting with a Floyd-Warshall algorithm in a language that does not like matrices, so something that lets my brain have a slightly easy go of it, I'm quite pleased with. So basically the idea here is we want to return n is equal to 1 because we know that is the obvious case, but we want to do something to n first because obviously we have other cases. So we want to basically say if it's made up of 2s, 3s, and 5s, let's go through and actually remove all of the 2 factors inside n first. So while n mod 2 is equal to 0, n equals n divided by 2. So let's think about what this will do. If we were starting with, say, 12, what it's going to do is it's going to take a 2 out and cut it down to a 6, and then it's going to take another 2 out and cut it down to a 3. So it's going to remove all of the 2s. If this was a, let's say, a 32, it's going to cut that down to a 16, which is going to cut down to an 8, which is going to cut down to a 4, which is going to cut down to a 2, which is going to cut down to a 1. And of course, that is our base case. We've hit a 1 because we've removed all of the 2 factors inside n. And it turns out that 32 is 2 to the power of 0, 1, 2, 3, 4, 5. 2 to the power of 5 is 32. So all of the factors of 32 are 2s. So it is an ugly number. But of course, if we go back to our 12 example, which we've cut down to a 6, which we've cut down to a 3, we now need to do the same thing while n mod 3 is equal to 0, while there are 3 factors divided by 3. So this would then get reduced down to a 1 as required to do this check for n equals to 1. And of course, if we actually started with a, let's say this was a 60, we take out the 2s, we get to 30, we get to 15, we take out the 3s, we get down to 5, and of course now we need to take out the 5s, while n mod 5 is equal to 0, n equals n into the division 5. This is our ugly number code. Let's give it a test. Looks like it's working. Let's use all the example test cases. I am not signed in. I have no idea why it's doing that. Someone mentioned in the comments, I'm afraid I forgot your name, that there's a new version of Leetcode which I don't seem to have. So I suspect perhaps there's A/B testing going on, which is causing funny interactions. That's interesting. Now I really can't stay signed in. Maybe it's just sending me the wrong error because I do click too quickly. Excuse the motorbike. That's all working perfectly fine. I say we submit it. It's awfully slow. Perhaps the algorithm is too slow. Time limit exceed. Ugh. What is the output for 0? Oh, hang on. This can be. I see what's going on. So this can be negative or positive or 0. So what we need to do is check that the absolute value is less than or equal to 1. So what this will do is it'll keep dividing n, and we'll either get down to, well, some number that's not 1, -1, or 0. It'll only reach 0 if it started at 0. But the idea is that if we started at, say, -60, does that count? No. We're told here it's a positive integer. Sorry, my mistake. So in fact, we can keep with our n equals 1 check down here, but just do a quick check at the beginning. If n is less than or equal to 0, return false. Sorry, that to check. Yeah, there we go. Perfect. So, before we call it quits, I want to say I don't like this code. I don't like it. And the reason I don't like it is we've got these 3 repeated chunks here. All of these are exactly the same, just with a different number. The 2, the 3, and the 5. So, let's factor those out. The uglies are 2, 3, and 5. For you in uglies, we want to do this bit here for each of the things in our uglies. And suddenly, we've removed all of that duplication and massively generalized our code as well. Because now, let's say something was also ugly if it had a 7, or perhaps it didn't have a 5, or something like that. All we need to do is modify this list, and suddenly our code is very easily adaptable to any definition of ugly number that we could possibly want. And that's what we're always striving for. So code, one way to measure how good code is how efficient it is, but another way to measure how good code is to measure how easy it is to maintain. This is easy to maintain in the face of likely changes that are going to happen. Now, you could argue the other version was easy to change. I can just copy and paste and add another thing. But let's say I had a mistake here. Let's say I had that as a bang equals, a not equals. That's obviously wrong, but if I hadn't noticed that and I'd copied and pasted it out 15, 20 times... Why can't I undo? Anyway, if I copied and pasted it out 15, 20 times, then I have to change it in every single one of them, whereas in this particular version, I fix it in one place, and my bug is fixed. Anyway, that's it from me this week. Do remember to like, comment, subscribe, all of that good stuff. I do hope you have a wonderful weekend, and I will see you next time. Bye.